is the DPF. We will see the DPF how it will reduce the particulate matter emission. So the DPF are the devices that trap the solid carbon particles, or it's also called as a carbon soot particle, preventing it to release from to the atmosphere basically. These are good in controlling the soot or a carbon soot particle. This DPF will accumulate the particulate matters, which will also cause high pressure drop across the filter. So you have two type of DPF. One is a wall through, and the one is a flow through. This is nothing but exhaust gas which is coming out of the engine from the DOC, and here the exhaust gas will get strike, and it will go to two directions, and finally it will go to a single direction. In the case of flow through, you have only single direction where the exhaust gas coming from the exhaust system from the DOC will go to the single path. It will take a single path, it will not strike, and it will go to the two different parts. So you have two types. One is wall flow type substrate type, and flow through substrate type. And basically, people prefer to go with the flow through, but still people are preferring to go with wall flow as well. It depends on the configuration. Uh, so here, this is one example of a wall flow uh, where the flow will strike, and it will go in two different directions and go to the final single direction. So when you're going for this DPF system layout, so we need to ensure that the DPF is designed for a sufficient lifetime, and also the volume we need to consider in such a way it should be capable of going for a big air storage volume. Um, and again, when you're going for the design activity, the distance, the thickness of the substrate is very much important. And again, you should ensure that the DPF system is good for the back pressure basically. It should be good for both low pressure, and also it should be good for a high pressure. And the stress should also be lesser, basically the thermal stress, because the temperature will be higher, and it should also have the high regeneration performance, and high heat capacity, and conductivity, and the resistance should be low, flow resistance should be lesser, and it should also be good for tuning respect to the substrate point of view. And you have the material called silicon carbide or coated. We use this as a substrate material, and you have the wash coating coat, and also you also ensure that the wall thickness should be on the lesser side, and the porosity cell density is also very much important. So you have again you have two type of system. One is underfloor system, and one is closed coupled system. When you're going for the underfloor system, you have the gap between oxidation catalyst and the particulate filter. Whereas in the case of closed coupled system, and the DOC and then the DPF are coupled together closely, where you don't have the distance. In some cases, these are preferable, and in some cases, these are preferable. Because you have some gap where you have some distance, but this configuration is also good in some system, but it will increase the space. If you want to reduce the space, then the integration is much more better. But bringing both DOC particulate filter together is also a problem, because the back pressure what you're going to get, you should ensure it. But when you're having some distance where the exhaust gas will go in a flow manner, where it will be very smooth to some extent, but achieving the pressure is also a challenging here. Again, we have three type of DPF. One is fuel borne additive system, where we have the temperature ranging up to 450 degrees Celsius. When the temperature is coming up to 600 degrees Celsius, we can go with the coated DPF type. And when the temperature is going beyond 600 degrees Celsius, basically a regeneration temperature, because this temperature is required to burn the carbon soot particle, okay, and which is nothing but the particulate matter we call. If you are not reaching that particular temperature, then you won't burn the carbon soot particle basically. And again, considering the traffic condition in India, where the traffic conditions are more, and you cannot achieve even 450 degrees Celsius sometimes. So in order to achieve the required temperature to burn the particulate matter, so you need to have some additive dosing unit. um, so you can use this additive dosing unit with the help of the electronic control unit, where it will increase the temperature by giving some by adding the dose into the exhaust gas, and the temperature gets increased. And when temperature gets increased, automatically the particulate matter will also get